Okay, on a little bit to class. Class is marketed as a decision support tool. It's a term I'm sure. I know there's quite a mix of people here. But it's provided as a decision support tool. It's used strategically inside businesses rather than operationally. What I mean by that is it's not a tool you use every day. It's a tool you use when you want to make a decision about your organisation, about your layout, about your warehouse. Two parts of the software. The first part is actually to draw visual designs. So you'll see when you get to use the tool, you can actually design these 2D and 3D images of warehouses very quickly on the computer using warehouse objects. So what you're looking at the moment is actually 3 chambers in a food wholesaler. There's a frozen chamber, chilled chamber, and ambient chamber. This view here, you're standing roughly where the mouse is looking back into the chilled area there, and the rack that's in there. So it has the layout capabilities and the ability to actually do the drawing side of things, but the other part is the ability to have the simulation capability to be able to predict how different layouts will run when you actually try to feed product in and out of that warehouse. So you'll actually see inbound flows, forklifts, conveyors, products moving around there with resources, shift patterns and all the things that you would expect to see in the simulation is there. Now I'm aware that some of you have probably worked in warehouses all your life. Others it might be a little bit new. I don't know if there's some people who are not familiar with warehouses, so I thought I'd put up a quick slide saying what does a warehouse look like. I chose 5 images. I could have chosen 50. They come in all different shapes and sizes, but then until you've been in one, they are basically big tin sheds, usually quite close to a motorway junction. Inside them, you'll have a whole raft of different ways of actually storing and holding equipment, all sorts of different racking combinations that you can get inside of different ways of storing it up in racking on the floor. Some of it automated, some of it not automated. You have different ways of picking and packing product inside the warehouses. This is just an example of a feed into different packing stations. And they come in, as I say, all different sizes and shapes. However, whilst warehouses look quite different, the actual basic processes that go on are incredibly similar. Basically, you're going to have product coming into them, you're going to have product coming out of it. Stuff coming in will come in from your suppliers, or your manufacturing base. The stuff coming out is stuff you're sending out either to an end customer, if you're doing internet shopping, or to a retailer, or whatever. So basically the warehouse is going to store the product coming in, it's going to pick from that product that's coming in and you're going to dispatch it. So when you actually come to see this actually running, although the shapes and sizes can be quite different, the basic processes that go on are very similar. So here's a typical warehouse that you might see. Looking basically inside there, this particular one is using 2 different rackings. We're looking vertically down on top. This is quite common for storing bulk, narrow racking, where you would actually have racking 4 or 5 high, sometimes higher inside a warehouse, and you get cranes putting things away into that racking for medium to long-term storage. At the top there we've got a pick face. What happens there is just an area, a bit like your Sainsbury's shopping aisles, where you'll be going around usually with a cage or a pallet, picking up different products from different locations to build up an order for a customer. The 2 key areas are the products that's going to come in. Generally it's going to be marshaled somewhere. You're going to put it on the ground when it first comes in. So you're going to get a lorry full of pallets or cages or loose cartons, put them on the ground, check them in, put them away. Then there's a reverse process. You're going to take stuff out from there, from the pick face, build it up in goods out and dispatch it out through the doors to go out in vehicles. The size, as I say, you see if you don't go inside the warehouse with the lorries travelling around the country, most of which are going to be servicing these types of buildings, and obviously you see the tin sheds, which are generally some of the most dull buildings you can see in the country. But just as I say, very quick whistle stop of what a warehouse looks like. Now, as far as class is concerned, again, I'm aware we'll have some people who are very strongly into simulation here, looked at different tools. Just wanted to position where class sits in terms of other simulation tools. Where I started my career was over this side. I've split it really into 2 sorts of tools, what I call generic tools and then domain-specific tools. So a generic tool is a tool you can use for any sort of problem, any sort of simulation problem. So you might be simulating the way a hospital works, or a post office, or a manufacturing site, any sort of process you can simulate. And there are a number of very good generic simulation tools out there. Flexim, Witness, Simulate, Arena, you'll come across a number of those names. And there's a whole host of what I call generic tools out there. And they can build any sort of model you want. What we've done with class is something slightly different. We've made it what we call domain specific, in that it will only model warehouses. So if you want to look at a factory, you don't use class. But if you want to look at a warehouse, that's where it really strikes in. Now why do we do that? Well, the advantages of doing it is that you can make it specific to that particular domain. So for example, when you're building it, you can build an interface which uses warehouse terms. So we talk about bays and docks and marshalling areas and racking inside the software. We don't talk about simulation terms which you might get traditionally trained on, like entities and attributes and resources and queues. We talk about things that are going to be known to the people in the business. Second thing is, with a generic tool, because it can be built to do all sorts of things, you generally need to build up the control logic. So how does a checking process or a picking process work? One of the things we do with class is we can pre-build all that for you. So that because the way that processes work are very common, all of that can be pre-set up for you, avoiding you the need to actually do some of the programming. And it's the same with reports, because the things you want to report on, generally speaking, are pretty much the same from warehouse to warehouse. We can provide all that ready for you. So, I suppose if the advantages for using class in a warehouse environment are those things at the bottom. But the disadvantages, it is limited to warehouses. So it depends really what you want to do. But in a warehouse environment, the biggest things that we get back is it's quick to develop. Because it's data driven, because you can set it up and all the logic's done, you can build these models very quickly. The first simulation I built using a generic tool took about 3 months to build. And I proudly went back to the user at the end of the 3 months and said, here's your simulation model, now you can design your answers. And he said, I'm sorry, it's too late, we've already done it. We had to build the warehouse, it's done, it's too late. So the great thing is, a lot of these decisions have to be done very quickly. When you get to a tool that's already sort of set into the domain, you can do that in that way. There's no programming required. So the second thing you'll see with class is that you can put it straight into the hands of the warehouse designer. Warehouse designers are the people who know all about, they've generally grown up in logistics, they know what all the different sorts of wrappings are, they know how a warehouse works inside out. They generally are not programmers. Got Mark Oliver sitting there. He's been doing warehouse design for DHL for 15, 20 years, Mark. Probably never programmed, but he can use class. So what you can do is put the simulation into the hands of the problem owner, which is something, again, which I found very difficult when I started with some of the generic tools, because although I understood simulation inside out, I didn't understand the problem inside out. And so it's a great advantage on that side of things. The third thing is, I suppose it's a downside of a domain-specific tool we don't do programming, is that occasionally you're going to get a problem which is particularly complex, where you need to do something underneath the surface. We do that sort of work, but we do it ourselves back using our own programming skills. So when we let people use class, if they have a particularly complex requirement, and some of the automated warehouses can get particularly complex, then we can add extra things into the tool and do that for people. So that's really where the class tool positions relative to some of the other products out there. Now what do you use it for? All sorts of different questions people come to us for. These are just some of them that are there. The big one in the middle at the moment, reduce my distribution costs. And this is the purpose of the example I'm going to do today. Distribution costs is something generally pretty hidden to people. Is how much does it cost to get that tin of beans from the manufacturer onto the shelf, ready for me to buy. And part of that is the warehousing costs. How much does it cost us to store it, how much does it cost to pick us? And you're down to pence. You're trying to save very small amounts off that thing to make you as competitive as you possibly can. So one of the key things we're looking to do is how you can design it to make distribution costs as low as you possibly can. But there are some other things that people have to put up with, mostly around change. One of the big ones at the moment is this one in the top left-hand corner, which is multi-channel fulfilment, which is a long and glorious term for the fact that generally speaking, it's the internet that's messing up a lot of businesses, because the internet is suddenly placing orders on business for individual items, which have been traditionally sold through retail outlets. So the traditional model is you would pick huge amounts, send it to a store, and people would come and buy it from the store. But now you want the warehouse to be able to send out individual items. So they have to change the way their warehouse works. And that means they have to change their labs, their resource levels, all those sorts of things to do. But there's other examples there, changes to WMS systems, growth patterns, all those things which are going to make the warehouse difficult to predict how to go forward. And using tools like simulation allows you to go into it and look and do it in a risk-free environment. As you know, you're all simulation practitioners, you know the advantages of using simulation. These are all great application areas for using simulation, which is why the class still is run up to that. How do you build it up? This is the way you build up the model. So that's that warehouse I showed you the plan. That's looking at it in 3D. What you do inside class is you're going to build up the layout, and you'll be able to have a go at some of this when you get your hands on the software. You put in all the building, the racking, the staging areas, you put it all in detail. Quite often start from a CAD drawing, but you can build up the physical model as a computer model on the screen. Once you've got it as a 3D model, you can rotate it and do all those nice things, walking through, around, but importantly use it to communicate your ideas to the people who are making the decisions. Once you've got the warehouse layout, you then need to put the process flow. So how does product move into the warehouse, how does it move out, and importantly, for most warehouses, what are the standard times that it takes inside your warehouse. So you will define into class, you'll use this task, which I say we've pre-built for you in class, you'll be configuring those tasks to say what sequence they happen in and how long they take in your particular environment. Once you've got that, you've got the layout and the process, you can then start to look at the throughput. So that's generally in terms of inbound flows and outbound flows, how much you're putting in, how much you're taking out. And you can stipulate that as data, and obviously with simulation, one of the things you're looking to do is to vary that throughput. So what would happen to my model if I increased it, decrease it? What would happen if similarly if I start to change the amount of resources I've got in there, or how I organise them, or what the shift patterns are? And like all simulations, I'm sure you've seen the idea of having visual outputs, so you can do the sort of normal 3D walkthroughs and see the thing moving on the screen, and it will give you the KPIs and the detailed statistics. Like all good simulations, it is an iterative approach. So you are setting your input data, running the model, see what happens, learn from that, go back and change the data until you actually tune that simulation to be right for what you need. Here's some real examples. Just some projects that we've been working on recently. Typically, we look at warehouses that's somewhere between 50,000 square feet and 1 million square feet. There's a variation between that. This happens to be a warehouse that's run by a company called CILT, 3PL, it's out in Belgium. This is one of the new co-op warehouses. A co-op called Summerfield. They have built a lot of blue warehouses over the last few years. If you go up the M1, you'll notice one about junction 20 and 28 is sitting beautifully up on the hill. They modelled and designed those warehouses using cars, just to see what they're going to look like and test the flows before they open them. This one's one a bit closer to my heart. It's a brewery in South Africa. With this area on the side is the empty bottles through the production lines, and these are the full drops, tins and cans ready to go out. Very interesting project. He actually used rail link, which seems to be happening more and more now for warehouses, actually starting to bring product in and out of the warehouses by rail to cut down their transport elements that go with it. Some in 3D. You obviously get the 3D. I'll just mention this one at the bottom, particularly interesting one. This is 3 floors of a 14-storey warehouse, which is a relatively unusual thing to see in this country. This was actually a warehouse in Hong Kong, and 3 floors inside that warehouse. Quite unusual for a warehouse in that you've actually got products being arriving at different floors and having to use a warehouse to do it. Well, that's going to be a short. And as with simulation, what you're looking to do with any model is you build the model up and look to see effectively the key question: if I change something, what will be the impact in terms of the output of that model. Lots of different things you might want to achieve, usually around cost, service levels, things like that, in terms of how the warehouse operates. All sorts of things you can change inside a warehouse, and so on, all those sorts of things. And I'm not going to go through these all now, just to give you an idea of the sorts of things you can do. Okay, that's an introduction to class. Anyone got any questions just generally about class at the moment? I'll start to move on to the example we're going to do here. Okay, what we're going to do here is look at a particular area. I mentioned it at the start called slotting. Slotting is a term that we get asked about an awful lot in the class. It's all around making things as efficient as it possibly can. Generic definition of slotting is all about making sure within a warehouse you put products in the right place within there so that they're as easy to access as you possibly can. It's something that we all do in our own homes all the time. If you've got a knife that you use regularly for cutting up in the kitchen, you put it at the front of the drawer. You don't put it at the back, so you've got to move everything. It's all about putting things in the right place so you can get at them very quickly. And this very much applies into warehouses. So what we're going to look at is how can it affect the productivity of the warehouse. So I'm going to just show you an example. We're then going to show you a base case model that we've built in class. We're going to then let you have a go at doing some of the experiments with it. Carol will show you how that's going to work. So, right, a little bit about slotting. ABC analysis, Pareto analysis. It's back to some good old theory somewhere along the line. 80-20 rule, often quite known as usually in inventory used about the cost of product, but it also can be applied to how frequently you're going to access it. The terms you hear in warehouses quite often are fast-moving products, slow-moving products. Fast-moving products is one you go to regularly. Every time you go in, you're always going to be like that, picking Coke. It's usually one of the fast movers. Rice, bread. Some of the slow movers are things that you use only once in a while. Brown shoe polish. It's still in your warehouse, but you're only going to pick it occasionally. Generally, you can go through your warehouse and you can look at the items that get picked most, and this is not uncommon. That you split them into different categories. So your A category, 15% of the items here account for 70% of the movements that go on inside the warehouse. 25%, the next 25% take you up to 90%, 60% take you to 100%. There are a lot of products in warehouses that sit there for ages. A lot of them are obsolete. You quite often go through warehouses and find pallets in the corner with dust on the top. People haven't picked for ages. Last year's stock. So why is it important to warehouse? Well, here's a very simple set of racking. Lots of aisles of racking going down through. That's where you're trying to gather it together. What we're going to do is just apply that Pareto analysis in here. So I've got 200 positions in my racking here, done specifically to make the maths as easy as I possibly could for myself. And so what I've done now is to apply that ABC analysis. So the red box here are my fast movers. If anyone's quick counting, they should find the 30 red dots on the screen. Similarly, for the greens are my medium movers, so I should have 25% or 50 of those on the screen, and the slow movers I've got 60%, so 120 slots. I like that. Now what I'm going to do now is create an order that I need to pick around there that needs 10 items. And if I look down there, what I'm going to do is to say, remember the other part of the analysis, the top 15% are going to account for 70% of my picks. So out of my 10 order picks, I've got to pick 7 fast movers, 2 medium movers, and 1 slow movers. I'm ignoring randomness in this rather simple example. So, now I'm going to do a pick group. This is the poor guy going out with a trolley who's got to walk around and collect all these things. So he's going to follow that dotted path roughly, visiting each of those locations to build his load. And don't read the numbers at the bottom, but I've basically added up the distance he needs to travel, apply the speed, and to do that particular route, walking around to pick those items will take him 209 seconds. So now I can do slotting. And it's all very, this is not rocket science to people here. Put all your fast movers together, so I still end up with the same number of red slots, same number of green slots, same number of yellow slots. And now apply exactly the same logic, I'll still pick 7 from the reds 3 from the green, 2 from the greens and 1 from the yellows, work out the calculation and I'll get a reduced travel time. As I say, no great surprise, so why doesn't everybody do it? We'll come to that in a minute. So if you then convert that into something a bit more practical for people, there's my journey times, 209 seconds versus 116 seconds. The time I actually pick is going to be the same. How long I spend at each slot's been the same, so I'm adding on 10 items at 7.5 seconds per item. Time at the start and the end of my route, so it gives me a total and it gives me a saving, 24%. Now that, you remember I talked about the pick costs. You're after saving pennies, 2p's, 3p's in terms of pick costs. What you're looking to do through this very simple example is you're talking about some very big potential savings in the time it takes to pick, therefore the number of people you need to employ. Oops. So it's all very simple. You should bung slotting in. There are unfortunately some big howevers that need to happen, which make it not so straightforward. The first thing is, if you put all your things together in one particular area, you're going to get lots of congestion. Because if you've got lots of people who want to visit that same locations, what you're going to find is they're all tripping over each other. So in most cases, actually congesting everything together as a fast mover might put you congestion into your particular system. For the simulation people may might have noticed the word might in amongst it, because obviously dependent on how much data you've got, how much traffic you've got through that. The other issue that's important to consider is that if you put everything close together, what impact is it going to have on replenishing the stock in each of those locations? So you need to do that. Then you come to the things which most companies will start to quote back and say that slotting isn't quite as easy as that. You can't just arrange things completely around the place as you want to, because there are issues like store-friendly pick. If you go into Sainsbury's late at night, you see them bringing pallets in to replenish their shelves, you'll notice they put the pallet at the end of the aisle, and all the products on that pallet are for that aisle. They don't need to move them around for miles. So what they do is they do what's called store-friendly picking, which means that you need to arrange your warehouse so that all the products for that aisle in the supermarket are in the same aisle in the warehouse. So you can't just put them, all the fast movers together, because you've got to keep them with the rest of the things that are in that store, in that aisle. You also have problems with heavy to light. If you stick light products at the bottom of the pallet and then you stick heavy tins on top, you're going to have a lot of damaged product. And there are other things in there that you need to take into account which makes slotting less easy. And there are also other strategies that you can do which will improve the amount of distance you cover, and that's what we're going to talk about later.